If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay students, I welcome you all to lecture 15 of this GATE Engineering Math Calculus series. So today I have taken 3 questions, 35, 36, 37. Some questions on directional derivative, differentiability, and then composite function for GOF. Okay, then let's start. So this is given to you fx. This is piecewise defined function. This type of function is known as piecewise defined because it is given in small pieces. This is one piece, this is piecewise. So this is known as piecewise defined function. So it is given a piecewise defined function where less than 1 this is this and greater than 1 this is this. R axis belongs to R. Which of the following statement is true? So you can see here the options are all using which one is differentiable, not differentiable, and that. So for this, for differentiable and not differentiable, you think of one that for differentiable first it should be continuous, then it is differentiable. It will be differentiable if it is continuous, then we can check, but reverse is not correct. So we start with first continuity. If it is continuity, then we will check for differentiability. This is the procedure. Consider continuity first, then differentiability. If it is continuity, then only you can go to differentiability. Otherwise you cannot go. If it is not continuous, then certainly it will not be differentiable. If it is continuous, then you have to check whether differentiable or not. Now you can see the breakpoint here. What is the breakpoint of the function here? The breakpoint, if you can see, the breakpoint is here 1, because below 1 is one type of function, above 1 is above type of another type of function. So from piecewise defined function, by seeing the breakpoint, you can get an idea where to check the continuity and differentiability. That means we will be checking continuity and differentiability at x equal to 1. So if at x equal to 1 we are checking continuity. Continuity means for left hand limit and right hand limit, that should be same. Left hand limit and right hand limit, it should be same. Now what is left hand limit? Left hand limit is x tends to a 1 minus, we will go, and right hand is we will go to 1 plus. Because it is piecewise defined, so it becomes very easy because already function is defined there, so you can put directly the value of a minus. So for less than a, what is the value they have given? E to the power x. So direct, what will be the value of the left hand limit? E to the power x, x is here 1. So this is left hand limit, because for 1 minus this is the function. For 1 plus, we will put it here. So if it is ln 1 plus a plus b, ln 1 is 0, so this is a plus b. So this is my first condition, a plus b should be equal to e for continuity. So for continuity, this equation means for differentiability also it should be true, because if it is not continuous, it will not going to be differentiable. Next, for differentiation, what you will do? You will differentiate it. You will differentiate it piecewise. E to the power x differentiation is e to the power x, ln x is 1 by x, 2ax plus b. Again, it is in two part. Okay. So what we will do? We will check left hand derivative and right hand derivative. So left hand derivative and right hand derivative we check again at x equal to 1. So left hand derivative will put 1 minus and right hand derivative 1 in the derivative itself. Now in the derivative we will put continuity. In the fx we have put x equal to 1, and for derivative we will put in f dash x. So if we put again e to the power, this is e to the power 1 less than 1, and for e to the power greater than 1 we will put it here 1 plus 2a plus b. So 1 by 1, that is 1 plus. So these two should be equal for differentiability. 2a plus b should be equal to e minus 1. This is your second equation. So obviously two equations, two are not, and both of them are independent. You can see the ratio are not same. You can deduct minus, then a will be minus 1 by 2. So you can calculate these two and you can find AB, but it is not required. You know that you will get some unique value of A and B, because we have solved so many simultaneous equations. We have seen what is unique value, what is all these in matrix calculation, linear algebra. You can see here these equation and these equation are not dependent, they are independent equations, separate equations. So obviously it will be differentiable for unique values of A and B, because you will be getting unique values of A and B. That is option B is the correct. So 35. Next is 36. So in 36, what is given? The value of the directional derivatives of the function this at the point this in the direction of this. What is directional derivative? Directional derivative is grade of f dot u cap. So what is grade of f? Grade of f is del del x of f I, del f del x I cap, del f del y j cap, and del f del z k cap dot unit vector. What is unit vector here? Unit vector is here I plus 2j plus 2k divided by magnitude of this 1 square, 2 square, 2 square under root. Because unit vector, you think it is cap means unit vector means you have to divide it. So if you put all this value here, finally when you will do the differentiation, you will get it. If you do the differentiation, you will get it y square with respect to x I am differentiating, so it will be y square then 2zx I cap, and then with respect to y z square plus 2xy j cap, with respect to z, with respect to that is 2yz and then x square k cap. So this is dot with I plus 2j plus 2k divided by 3. So 1 by 3 will be gone, and then you can put I dot will be I j k k, and you put x y z. These values are given. X is 2, y is minus 1. So minus 1 square plus 2 into 1. I cap I means 1, and then z square is 1 square plus 2 into y is minus 1. J you will get j and 2j, so 2 will be there, and then plus z, this one 2yz, 2 into y is minus 1, z is 1 plus x square is 2 square 4 into 2. So if you do this one, this will be 5, then 1 minus 4 3, that is minus 6, and then plus 4 minus 2 2 2s are 4. So it will be 3 by 3, 1 is the answer. That is, I think, option A. So you can refer directional derivative classes, the theory classes, lecture 1 I guess, to find this formula and what is the meaning of directional derivatives. We are looking at a particular directions, some physical meaning we have discussed there. So in 37 it is given gx is given, fx is given. So you need to find fog. Fog means composite function, that is f of g of x. So for doing these composite functions, I always take an example of, you always think there are two kings. F is a king and G is another king, and these two kings are very fond of fooding. They have different styles of taking food. F takes food in a different way, G takes food different way. So their feeding style is different. They want different types of foods for them. So here f of g of means G is inside, F is outside. So whatever G takes, G will give some output, F will take that as an input for it. Means F will eat that what G will give as an output. Here in place of G you can put, this is minus x, this is x plus 1, this is for x is less than equal to 1, this is for x is greater than equal to 1. So this will be going inside the F, but F will not take food like this because F has a special requirement. What F takes food? F takes food for less than 0 it takes a separate way, for greater than 0 it takes a separate way. Think about F, because I am writing for F now. So F will take food in different way. It will take food, it will treat negative values in special way, it will take positive values in a special way. That is the criteria of F. It will take non-veg in a way and veg in a different way. So it will food in different way, you can think. If it will eat in different way, it will take food in different way. For less than 0 it will take this, for less. So that means I have to check where it is less than 0 and where it is greater than 0. So if you think the output of G, what G is giving, if it takes less than 1 then it gives minus, if it is greater than 1 then it gives in this fashion. So now you think when it will give negative, because F will eat negative values in different way. So less than 1 means it can start from minus infinity, then 0 to 1. So if it is negative x here, minus infinity to 0, then G will give a positive. So F will eat it in a different way. If G is in between 0 to 1, then G will give negative, then F will eat it in different way. Okay, that means I have to break it here. That means if my x is less than 0 or minus infinity to 0, you can think, then it will be a positive value. It will give positive G. G will give you positive output. Why? Because G, you see, it is minus x. So if you are giving this, then G will take positive. Okay. Now, if x is between 0 to 1, then what G will give? G will give negative value. For 0 to 1, it will give negative value. And if x is greater than equal to 1, then it will be positive value. Okay. This is the way G's output will be distributed. I have calculated the output. this is G's input, this is how G eat, this is how G gives output. So G gives output in this way. You put the values and check how this G is giving output. So as G is giving output, F will take it as an input. Okay, now what will F do? F will, first you will start with this value, x is less than 0. You can write or minus infinity to 0. Okay, if it is less than 0, then what is the output of G? Positive. So F is going to eat positive thing. How F eat positive thing? It eats positive in this way. If it finds positive F, then it squares it, makes it square. Those food you are giving, it will just take square of it. So what F is getting here? It is getting positive value, but what is the value it is getting? Because in this range, what is G is giving? This all comes from this. These two comes from this one, less than 1. So what is G giving? F. G is giving F minus x. So what F will do? It will square it. So that means it is x square. You can write it, or you can write it is x square. Okay. Next G is giving negative food. So F what will do? If it gets negative, then it's 1 minus that food it will do. It will do whatever input, then it 1 minus, subtract that input from 1. So 1 minus, what is the input? Input means G, what it will give. What G will give in this case? 0 to 1, G will give this. So it will just make it 1 minus. So it is 1 plus x for x less 0 to 1. And for x greater than 1, what G gives? G gives plus. So what it does for positive values? It just square it. So what is the value G is giving for greater than 1? X plus 1. So it will just square it. So finally, if you write fog, you will have 3 parts: x less than 0, and then 1 plus x from 0 to 1, and then x plus 1 whole square. Okay, now they have asked to find, once this is done, then the answer is easy. Discontinuity of fog with respect to minus infinity to 0. From minus infinity to 0, what is the discontinuity? That is in negative value. So negative value only, this is the function. What is the function for negative values? X square. If x is in between this, you can see, if x is in between this, then what is function? What is fog? Fog is only x square. So x square means it is always, do you have any discontinuity in x square? You can, discontinuity means if you put any value, then you will not get real value, output as a real value. X, you can put any damn thing, but the output will be always a real value. You can always find the square of any numbers. So that means no discontinuity. So that is option A, 0 discontinuity. So I think you got it, how to calculate fog. You think is two different things. First, fog means you write G, then you think how G gives output, because you write the outputs of G, because F is going to eat it. So you have to write the outputs of G and see the how F eats its food. So you check it, and accordingly you give the inputs to F. You check the food habits of F, how it will going to eat, and as per that you write the outputs of G, how G will give the output, and now you feed F. Got it? If it is positive, then feed F positive values. If it is negative, feed F negative values. If it is some other things, you can feed. So you have to check the food habits of F and G both. Especially the outer one is the most important. Here outer one is there. So you have to take care of the food habits of F, how it is going to take the foods. So your G output should be broken into pieces. G's output, this is the G's input. So G will give output if you put minus 1 less than or greater than 1. So different outputs will come. So G's output need to be broken. You have to check G's output because F is going to eat. So what is G is giving in the output, you have to check it, and accordingly you have to feed it. So I think that's all for today. We will see in next class. If you liked the video, then press the like button and please give your valuable comments in the comment section.